Hey, so today I'm going to show you a couple of switches and how they're built, the internal workings, common faults, and a couple of other juicy things. So let's get down to it. So here we have a two-way switch. It switches on multiple lights from one location. One or multiple lights from one location. This is a three-way switch. It switches on one or multiple lights from two locations. And this is a two-way switch, paddle switch. These are toggle switches. Paddle switch because it has a paddle. And this one up here is a dimmer switch. It's a modern dimmer switch. So it functions a bit differently from a mechanical dimmer switch with a slider that moves up and down. So we'll start with the two-way switch. And here's the here's the inside of the switch. How it works is when you press the toggle up and down, this piece right here pushes against this metal piece in the back. And what it does is it pushes the contact away from the contact here. So as you can see, there's this long metal piece at the back here, and right under there is where it connects. So as the switch is pressed, it pushes it away. That turns the switch off, and you press it the other way and it turns the switch on. That's a two-way switch. The wire is wrapped around these screws. Now, if it's not wrapped around the screw, then it's pushed in the back, and there's a hole here, up here, and down here. Now, let me see if I can take this out to show you what it looks like when the wire is pushed into the back. So where that hole lines up, it lines up right over here. Now when the wire is pushed in the back, so we'll get out a piece of wire and we'll push it in. I'll see what that looks like. So you can see it goes in pretty easy and doesn't come out pretty easy. I'm going to pull it and it scrapes against it. There's a lot more pressure to stop it from coming out because of the way it's designed and sits inside the casing. If I push that in right now, this wire is a bit too big. So that's how it sits inside there, and it's just touching those two. It's not really compressed. So a wire that is inserted into the back is not as secure as a wire that is wrapped around the screw and the screw is tightened around it. That's I would always recommend putting this wire underneath the screw instead of pushing it through the back. And what tends to happen over time as the switch is used and heat is generated, these two contacts are different material. I believe they might be a mix of copper and aluminum, and they wear down, and that's the first thing to go in a switch when it breaks, unless the wire was pushed in the back and the heat generated and this some arcing and the contact no longer works properly. But generally that's the first thing to go. As you can see, push. Okay, so that's a two-way switch. Now we're getting to a more technical side of switches is the three-way switch. The three-way switch has three wires going in, and they work in a way where two sides are functioning each time you press the switch. So there's an open and close when you press the switch. Let's see how it works. So the switch has 2 points of contact to it. See if we can get this. That'll sit in, held in place in the spring. As you push this, as the switch turns, it breaks the contact on one side, and then as it's turned the other way, it'll reconnect the contact on the other side. Now let's see where the contacts are. This is the main moving part. So as you can see, there's a connector and there's a connector. That connector connects to here. As it's pushed, this switch, the contact moves up, and this contact stays connected from here to here. This is the constant hot, the live, that is always hot, no matter which side of these has power. This one always has power, or this one is always connected to the light. So depending on the side of the room you're on, one of these switches, three-way switches have two switches connected to the light. Let's just establish that again. So this wire on both of those switches is either going to be going to the incoming hot or the outgoing wire to the light. These two are traverse wires. They connect to the same side on the other three-way switch. So when this connects to here, when this connects, as in when the switch is up, push this down in place so that it shows the correct. Okay, so when the switch is down this way, this piece is pushed down, disconnecting from the bar across. When the switch is pushed up, this is pushed down, disconnecting from this screw. So when this one is disconnected, this one is connected. It runs across here and up there and across. When this one, this is still connected over here, still connected there. When this one is pushed down, then the current is running up to here, but not connecting to that one that's pushed down, and is running up here. And again, what goes first, what breaks first in these switches is overheating, overloading, and causing these connectors from use to wear down. And when they wear down, then they stop connecting with each other. So that's one of the faults that could happen in these switches. And it also has holes where you can push the wire in. These ones have a different setup for how the wire is held inside the housing. There's another metal piece. Let's take it apart and show you. As you can see, that's there. Connects on top. this is the metal piece that the wire is held in to the housing with. As it's pushed in the back, it grabs that. This wire is too thick. It grabs that piece right there, and once it's in, it doesn't pull out because of the way this has been designed. It's like this. Wire goes in, catches the side, and boom, can't pull it down. Can barely see that. There it is. Catches it on the side like that. That's it for the three-way switch. I hope that was helpful in understanding how it works. The next one is the paddle switch. So the paddle switch had to be opened. Interestingly, these switches are held together with this metal. It's like clamped on both sides and locks in place on the top here. This paddle switch is not built as sturdy. It's built differently. I mean, it's pretty sturdy. The difference is this is glued. I heated up the switch a bit and was able to pull it off. That was glued, and this metal frame locks the front part onto the back with these hooks going through the sides here. So it's sturdy. It's just when something has glue, I think it's a bit less sturdy, but the frame is holding it all in place. So there's nothing wrong with these switches. They're built well, it's just built differently than the others. So this is a paddle switch, and this is the main connector. This travels in between the two sides, connecting the connectors here. So I'll try and pull those out to show you if I can, if it's not glued in. You can get a screwdriver or a plier. There we go. So here's the holder for the traveler, and you can see there's a wire stuck in, and that's great because now I can show you. You can see how it sits inside. If I can make it clear enough for you to see. There we go. So you can see how it sits inside, and you can see how it cuts at the copper when it's tried. When you have to pull it out, it cuts the copper, and that weakens it. So if we push it in a bit, oh, it came out. Okay. So you can see how that's designed. Kind of with teeth, it kind of holds it there. But the screw with this clamp around it is going to be a better connection in all situations. So that's highly recommended, and that is not. So this is the clamp, the holder for the connector. So one side turns the switch on, connects with the contact on the other side. And like so, and when it's turned, it disconnects and just kind of sits there. Doesn't go that far, doesn't touch that. I mean it could, but it's not connecting with this side, so it might touch that side. It does nothing because it's staying on its own side and not connecting with the other side. So it's like that. Boom, switches on, switches off, switches on, switches off. And you can see there's markings on these points. That's from like overheating, electricity running through creates heat, those contacts. As it goes like that, it creates an arc as it's moving. Once it connects, then the arcing stops. But that's a very small point of contact. And that's going to generate some heat. And that's why these will wear down eventually. And that's what breaks in these paddle switches. Next we have a dimmer switch. This is a modern tap switch. You just tap it either side. There's no mechanical movement because these have buttons. These are the on-off buttons, and these are the dim buttons. As you can see, there's quite a bit of hardware in there, and the internal relay is the first. I think it's the relay. It's the first to go because of the heating of the dimmer. So that's why these cost more money. There's basically a transformer inside, and they're not worth it to fix when you can just buy one for less than the price it would cost you to fix it. So these don't have points where you push the wire in. These the wire goes in the sides here. This is a three-way. Why is there a black, a gold, and a pink? So that's a good question. The pink, I don't remember. I don't know why it's labeled pink. It could be to let you know that that's the traveler, a specific traveler. Both of these are going to be travelers. You might want to know which one is the traveler on this side. Honestly, don't know why it's pink, because the black one is the common. That's where the hot wire goes into, and these two would be the travelers. But anyway, this also has LED lights. So over here you can see 2, 3, 4, 5, 6, 7, 8. Those are lights to let you know the level of the dimming. And really that's all I have to say about this dimmer switch. Pretty sturdy design. It's stuck to the back here. It's gone through there and here. It's not going anywhere. I wasn't going to drill those out to show you. And that's it for switches. Let me know if you have any questions.